Now I am going to discuss about thermistors. So thermistor, what is a thermistor? Thermistor means it is having two terms. One is thermal resistor. So the thermistor is a resistance thermometer. That is a resistance thermometer or a resistor whose resistance is dependent on temperature. So that means you can measure the temperature. You can measure the temperature by measuring the resistance. So the term is called thermistor. That is thermal resistor. So it is made up of metallic oxides pressed into a. It is having different. It can be available in different forms. So it is made up of metallic oxides. So these are pressed into bead or disc or cylindrical shape and then encapsulated with an impermeable material such as epoxy or glass. And the different types of thermistors are negative temperature coefficient thermistor, positive temperature coefficient thermistor. So negative temperature coefficient thermistor means whenever the temperature increases, the resistance decreases, or when resistance increases, the temperature decreases. Both are inversely proportional. So usually thermistors are available in NTC thermistors only. And there are also PETC thermistors, those are positive temperature coefficient thermistors. But these are not available in abundance. Only NTC thermistors are used. The circuit symbol of this thermistor will be like this, the variable resistance. And sometimes it can be measured, it can be indicated like this also. So for NTC thermistors, that is negative temperature coefficient thermistors, if you plot a graph between temperature and resistance, if the temperature goes on increasing, the resistance decreases. These are called negative temperature coefficient thermistor. So how you are going to measure the temperature means first you need to measure the resistance. So how you are going to measure the resistance means see here this thermistor is connected to a battery here and in series you are placing an ammeter here. So that means this is the current indicated and this is the voltage. Voltage divided by current will give you the resistance. So if you measure the resistance, what happens is you can measure the temperature from the graph. You can measure the temperature. This is how you can measure the temperature by using the thermistors. And the uses of thermistors are these thermistors can be used in digital thermometers. So thermometers will be used to indicate the temperature. So these are used in digital thermometers and also these are used in automotive applications to measure the oil and coolant temperatures in cars and trucks. And these thermistors are also used in household appliances like microwaves, fridges, and ovens. And these thermistors are also used in circuit protection, that is, surge protection. And these are also used in rechargeable batteries to ensure that correct battery is maintained, battery temperature is maintained. So these are the different applications of thermistors. Next one is thermocouples. This is the construction diagram of thermocouple. So in this construction diagram of thermocouple, you need to maintain two junctions here. One is constant hot junction and the other one is cold junction. So hot junctions means where you need to increase the temperature. Here you are placing some candle or so like that so that you can increase the temperature here. And this is the cold junction. So in between these two junctions you are need to place two wires. This is type A wire and this is type B wire. These two wires are placed between hot junction and cold junction. In other terminals of this cold junction, in between these two, you are placing a voltmeter here so that you can measure the voltage. This is the construction diagram, and the working principle is when the temperature is increased at hot junction, the cold junction is taken as reference. So there is a difference in the temperature. So when there is difference in the temperature, what happens is an voltage is induced here. So that voltage is indicated by the voltmeter. So this voltmeter will measure the temperature now. So this is the working principle of thermocouple. Next one is synchros. So synchros is a type of transducer which transforms the angular position of the shaft into an electrical signal. So these synchros can also be used to measure the used as error detector also, and as a rotary position sensor also. So the uses of the synchros are you can measure the error as well as you can measure the rotor position. The error occurred in the system because of the misalignment of the shaft. So always the error occurs because of the misalignment of the shaft. That error can be calculated by using the synchros. For the error detection, you need to use a transmitter as well as a control transformer in the synchro. First we shall see how a synchro will be. So this is how the synchro transmitter will be. So this synchro transmitter will be consisting of two parts, that is stator as well as the rotor. So these three windings are nothing but the stator windings. So this is the stator on which the stator windings are wound. And inside of this stator you can see this is the rotor and this is the rotor winding. So for the rotor winding you will be applying the voltage, and this voltage can be measured. So here for the rotor you will be applying the voltage here, and the voltage applied is of form VR is equal to root 2 sine omega t. See here, this is the transmitter, synchro transmitter. For this R1 and R2 indicates the rotor windings, S1, S2, S3 indicates the stator windings. These windings are displaced from each other by an angle 120 degrees. Suppose this rotor has moved at an angle theta r, then what happens? How you are going to measure the error? That we shall discuss now. Suppose Vs1, Vs2 are the Vs2, Vs3 are the voltages induced in the stator windings S1, S2 and S3. So this Vsn can be indicated as kVr sin omega ct and cos of theta r plus 120. And Vs2n is equal to kVr sin omega ct cos 2r. That means all these three voltages, in between these three voltages, they are displaced by 120 degrees. And the three stator voltages can be found as Vs1 S2 is equal to Vs1n minus Vs2n. So that means you can measure the stator voltages by using these formulas. So you can, from this you can measure the stator voltages. Next, how you are by using this you can measure the rotor position. And for error detection purpose, you need to use a synchro transmitter as well as a control transformer. So synchro transmitter consists of the same S1, S2, S3 windings, stator windings, and a rotor winding. And the control transformer is also similar to the synchro transmitter. So here also S1, S2, S3 stator windings would be there, and the rotor is at an angle is perpendicular to the rotor of the stator transmitter, synchronous transmitter. So these two rotors are perpendicular. So that is the only difference. Now to measure this error, how you are going to measure is, suppose this rotor has moved at an angle theta r in the anti-clockwise direction, and this control transformer rotor has moved with an angle theta c. So the difference between these two angles indicates the error. That how you are going to show, that is from these equations. Now the voltage applied is given by E of t is equal to kVr cos pi sin omega ct. Now consider the position of the rotor and the transmitter is changing in the same direction. An angle theta r deflects the rotor of the transmitter, and theta indicates the control transformer angle. Now the total angular separation between the rotors, that is phi is equal to 90 minus of theta r minus theta c, that is 90 minus theta r plus theta c. Now if you substitute this phi in this equation, then what will you get is E of t is equal to k dash Vr cos of 90 degrees minus theta r plus theta c sin omega c. That means cos 90 minus theta is nothing but the sin theta. So k dash Vr sin theta r minus theta c sin omega t. We know for small displacement we can consider sin theta is equal to theta we can take. So sin theta r minus theta c is equal to theta r minus theta c. So that means E of t is proportional to the angle now. E of t is error is proportional to the angle. So that if you measure the angle difference, then you can measure the error signal. So the error signal is applied to the differential amplifier which gives the input to the servo motor. The gear of the servo motor rotates the rotor of the control transformer. So here you can consider this is the angle difference, that is theta r minus theta c, and this is the carrier signal likewise. This is modulating signal and this is carrier signal. So you can get the modulated signal like this. So this is nothing but the output voltage which indicates the error. So this is about the servo motors. Okay, now the applications which the servo motors are used are for error detection as well as the angular position. Okay, this is about the servos.